All right, so differentiability, when we say differentiability, it's the ability to do what? Thank you. To take the what, though? Derivative, right? It's the ability to take the derivative. But what it's really saying is that when we took the limit as x approached c of f of c, what did we say? What had to happen if this is c? The limit on the what? Left has to equal the limit on the right. So there's another companion to this having to do with differentiability, that if we want to say that the derivative at c exists, we have to have not the y values, but the what on the left has to equal what on the right. Yeah, the slope. The slope on the left. The slope on the left has to equal to the slope on the right. Just fits. It just fits. So is this continuous, this absolute value of x, is it continuous at 0? Is that continuous at 0? Yeah. Y on the left is 0, y on the right is 0. Is it differentiable at 0? No. Yeah, this is where people would go, oh, wait a minute. The slope on the left is -1. The slope on the right is +1. So at 0, which is it? I don't know. It's neither. So we would say it's not differentiable at x equals 0. So for this thing, it's differentiable everywhere except 0. 0, it's not okay. Derivative on the left is different than the derivative of the right. And when we looked at derivatives, we looked at f of that value plus x minus f of that value over h. Did that ever confuse you, or does that totally make sense? Here's your function, f of x. If this is a, what's this? Y value called f of a, right? Now, if we go over a skosh, I love that word. Go over a skosh, what's the new x going to be? A plus h. Now, what's this y value? F of a plus h. Is that hard? No. So the slope is the change in y, which is what? F of a plus h, this y minus this y, all over what? Which is just h. That's the slope. Now, what should h be to get the derivative at a point? Yeah. So to get the derivative at a, you take the limit as h gets very, very, very tiny to 0. This is called the derivative at a point. And I don't know if you've ever seen that before. At a point. You've seen the general one. The general one is instead of a, they give it a variable x. They call this x, x plus h, f of x plus h. So the derivative, the general equation for slope is as h approaches 0, f of x plus h minus f of x over h. This is the general equation for slope. But it's just as helpful knowing about the slope at a point. Super helpful. Sound familiar? Remember all that? Okay. So if you want to prove continuous, all that you do there is you check the y values. Y on the left, y on the right. But what do you have to do if you are looking for differentiability? You've got to check the slope. So you need to be able to take the derivative of sine and the derivative of x squared plus 5. Now I know I know you know the derivative of x squared plus 5x. You memorize that, and once you memorize it, it just totally stuck. What is it? Oh, love that. It was like the best part of calculus, wasn't it? It's like eating a sandwich. It's just the best. So easy. It's there. You got it. No problem. But how about if f of x is sine x? This is where you ran into some trouble. What's the derivative of that? Are you sure? Sure it's not negative cosine? Positive? Well, let me show you real quickly how you can always remember that it's regular cosine. Here's the sine of x graph, right? Okay. And y equals sine x. So you're good with that? You're saying that the derivative is cosine of x, right? What's the y value at 0? I don't like that color. 0 for sine. 0, 0, right? What should the slope be at 0? 1, right? Shouldn't it be 1? Okay. So what's the derivative of sine? You say cosine. What's the cosine of 0? It works. That's how you can remember. Or if you ever get it mixed up, it works. What if you said negative cosine? By the way, that's the antiderivative. If you get them mixed up, and you drew the picture, can you see there's no way that slope is negative 1? So that's not right. Okay, good. But I'm actually going to prove the derivative of sine because I think it's important. And we'll prove the derivative of cosine. We'll do these real quick. First, two helpful formulas. We just did f of x plus h minus f of x. That's the change in y. Change in x is h. Slope is change in y over change in x, and shrink h to 0. You'll get the derivative. Don't forget sine theta over theta. Did I ever show you what cosine theta minus 1 over theta was? Beginning of the hour. I showed you that. And I think I did 1 minus cosine. What was 1 minus cosine over theta? 0. So what do you think cosine theta minus 1 is over theta? It's negative 0, correct? No. Okay. Let's see. So here we go. Why am I showing you this? Because I am the great math unifier. I love unifying math. I love what we did last chapter. I want you to see why we did that last chapter. We did it for this reason here. If you take the derivative of this, it's the limit as h approaches 0 of, make my day, sine x plus h. What are we going to be using? Yep, sine of x. But what are we going to be using? Sine x plus h. What are we going to be using? Stan knows. Seco cosi, yeah. So we don't do things for no reason. We do these because all of math connects to itself. And you're going to see, I like to bring up, my favorite thing about math is bringing up when things connect. And this is definitely a connecting moment. Limit as h approaches 0 of the sine of x times the cosine of h. For sine here, it was plus the cosine of x times the sine of h minus the sine of x all over h. Yeah, so this is going to be the limit as h approaches 0. I think Mr. Fry did this last year, but I'm going to do it again because I think it's important. We want to take, he didn't do this? Oh, I bet he did. I'm sure he did. I'm sure he did.
He did, but I'm pretty sure he didn't talk much.
All right. So now what we're going to do is we like this sine theta over theta. So if we're going h approaches 0, it's going to have to be sine h over h. If I label these A, B, C, which of those terms is going to match with h here? A, B, or C? I like your idea. Look at what happens with B. you have the cosine x times the sine of h all over h. And then what's left is going to be sine x times cosine h minus sine x over h. See how I split that up? Just fraction. I put these two together for this last part. Sine x plus cosine x minus sine x over h. And then this one, I have cosine x times sine h over h. All right, I think we better do one more step here. Limit h approaches 0. Cosine x times sine h over h. And then what do you think I'm going to pull out in front here? Good. Sine x cosine h minus 1 over h. And let's see something wonderful happen. What's something wonderful that's going to happen? What is sine h over h? What's that? Love it. 1. And what's this equal to?
0.
Yes. And why is that a good thing? Because that takes out this sine x. Sine x times 0, you're going to get cosine x times 1 plus sine of x times 0, which is just going to be the derivative of sine of x. I'm going to write it. Probably the best way is d dx of sine is cosine x. You like that? Prove that one. What do you think, Lauren? Good? Okay, then you do this one. You do cosine. Good luck. So we have the limit as what we're looking for is the derivative. So we would say f prime of x is the limit as h approaches 0 of cosine x plus h minus cosine of x over h. Now most people would be afraid and fearful at this point, but not you, because what's your big move here? CC, cosine x, cosine h. This is a plus. This will be a minus sine x, sine h, minus cosine x, all over h. I'm going to do this little helpful hint. I'm going to rearrange these, so I'm going to put this negative sine x sine h first, plus cosine x cosine h, cosine x last, and then I'm going to just split these into 2. Does that help you a little bit? So this is going to be the limit. H approaches 0 of negative sine x. Put the sine h over h. Take out a cosine x. You get cosine h minus 1 over h. And of course, what does this go to? 1. And what does this go to? 0. So you're left with the derivative of the cosine is negative sine x times 1 plus cosine x times 0, which is the derivative of cosine is negative sine. How many got that? Fantastic. So now what you can do you remember all these other derivatives? Tangent, cotangent, secant, cosecant. We'll keep practicing those, and we'll see more with that tomorrow. But you can look those up. For homework tomorrow, I want you to show that this is continuous but not differentiable. I'll let you play around with that one. Explain why this one is not differentiable at x equals 0. Same with these. And all these have to do with differentiabilities. 7 is fantastic. All of these are good. And then what I would like you to do is see if you can do 1A and B. I'm not going to say anything about L'Hopital's, but you can do 1A and B. Video will be